For the last 30 years, Albert Einstein chased a ghost. He wanted to write a single, elegant equation that explained the entire universe, a unified field theory. But this mathematically beautiful pursuit ended up as his greatest failure. Einstein had a specific target in mind. He wanted a theoretical weapon to mathematically dismantle the rising tide of quantum mechanics, a new field he deeply distrusted. To accomplish that, he needed to force the universe's two known macroscopic forces, gravity and electromagnetism, to obey the exact same set of physical laws. At the time, general relativity had elegantly defined gravity as the physical bending of space and time. Electromagnetism, however, remained completely separate, operating as a messy, independent phenomenon. Having two entirely distinct rulebooks for reality was philosophically unacceptable to him. Nature, Einstein believed, had to be logical and singular. So he committed to a radical idea. Physical forces don't actually exist. In Einstein's ideal universe, pure geometry is the only reality. General relativity treats space and time as a physical fabric, where heavy objects warp the coordinate system. But expose that elegant model to a second force, and the math breaks down. A four-dimensional grid lacks the mathematical room to explain magnetic attraction. Because those four dimensions were entirely occupied by gravity, physicists realized the only path to unification was to invent more space. In 1919, a mathematician named Theodore Kaluza bypassed this geometric deadlock by flat-out cheating reality. Kaluza injected an entirely invisible fifth dimension straight into the equations. He proposed that this extra spatial dimension exists everywhere, but it's curled up on itself, infinitesimally small. In this model, an electromagnetic wave is gravity operating within these tiny five-dimensional loops. Einstein read the paper and was deeply enthusiastic. He viewed Kaluza's five-dimensional cylinder world as a logical triumph. This triggered a massive wave of theoretical output. For the next decade, physicists pushed the math further, experimenting with concepts like distant parallelism and complex asymmetric metrics to force the numbers to align. But there was a catch. This hyperdimensional math synthesized the forces perfectly on paper, but it demanded a universe completely detached from human observation. Einstein and his collaborators retreated into this abstract realm. They relentlessly churned out theoretical papers, isolated from the experimental physics happening outside their doors. They had fallen into a deductive trap. Instead of adapting their work to new empirical data, they relied entirely on building up from their own speculative assumptions. These elegant geometric models suffered from a fatal physical limitation. They couldn't predict a single new physical effect, and they utterly failed to explain basic observed realities, like the mass difference between an electron and a proton. While Einstein was drawing extra dimensions, a new generation of physicists was mapping the atomic world. Quantum mechanics posed a direct, inescapable threat to Einstein's clean geometric worldview. The new quantum wave functions operated on an entirely different philosophy. They described a microscopic reality governed by statistical probability, randomness, and chaos. This jagged, unpredictable quantum reality clashed entirely with the smooth, deterministic nature of Einstein's spatial grids. So Einstein made a massive theoretical gamble. He held a steadfast belief that a completed unified field theory would naturally absorb, explain, and overwrite quantum mechanics. He spent decades running the calculations, searching for that proof. But his purely classical equations never derived the quantum properties of matter. The unification quest failed because Einstein stubbornly rejected the messy, probabilistic nature of the universe in favor of mathematical perfection. By the end of his life, his relentless pursuit of this classical unified field theory left him scientifically isolated from the mainstream physics community. But the specific mathematical tools invented for this failed quest did not die with Einstein. Decades later, modern physicists resurrected Kaluza's invisible dimensions and the geometric gauges created by his peers, using them to construct modern gauge theory and string theory. Einstein was wrong about the physical reality of his era, yet he inadvertently built the mathematical engine for the modern search for a theory of everything. Look at the historical record: the desire to geometritize forces, the invention of hidden dimensions, The failure against quantum mechanics. The accidental foundation of modern physics. The mathematical tools Einstein forged in failure now serve as the primary language for physicists mapping the universe's hidden architecture.